Welcome to Tipping Points and the impact on the carbon cycle for AQA A-Level Geography. The carbon cycle is a delicate balance that governs the Earth's climate. But what happens when that balance is disrupted? Now, tipping points in the carbon cycle are critical thresholds that hold the world in balance. Small changes in environmental conditions can trigger massive and often irreversible shifts in the Earth's systems. Once crossed, these tipping points can set off feedback loops that intensify climate change, making it far more difficult to mitigate. Let's start with the Amazon rainforest dieback. The Amazon acts as one of the world's largest carbon sinks, absorbing vast amounts of carbon dioxide. But if deforestation and warming continue at their current pace, the Amazon could transition into a savanna-like ecosystem with significantly lower capacity for holding carbon. This could lead to the difference between its ability to be able to store carbon and even releasing the carbon that it currently holds, particularly within biomass and soils, otherwise referred to as the biosphere and pedosphere. Rates of soil erosion could also increase, releasing more carbon into the hydrosphere. The next tipping point is the melting of Arctic permafrost. Permafrost contains intense amounts of organic carbon, frozen for thousands of years. We see these scenes now in northern Russia and in the other parts of the Arctic Circle, where Ice Age animals are now being revealed for the first time in history. As the Arctic warms, this permafrost thaws. This releases both carbon dioxide and methane. This greenhouse gas is much more potent than CO2. It has been recorded to be between 15 and 21 times more powerful as a greenhouse gas. This creates a dangerous feedback loop that can further heat the planet, releasing further stores of carbon. Our next tipping point is the collapse of the Atlantic Meridional Overturning Circulation, or AMOC. You will have learnt about this in lessons as the ocean carbon pool. This critical system, or part of the Gulf Stream, redistributes heat across the planet. Melting ice from Greenland and the Arctic could disrupt this system or even shut it down entirely. This would obviously affect the carbon cycle, but also the UK's extreme weather patterns. The West Antarctic ice sheet is another major concern. If this vast ice sheet melts completely, sea levels could rise by up to several metres. Beyond that, as ice melts, it exposes darker ocean surfaces that absorb more heat than surrounding ice. This is due to the reduction in the albedo effect. This would make warming accelerate even faster than before, decreasing the chances of a cooler climate. Finally, the boreal forest dieback. Boreal forests are typically found in the Arctic Circle. Now, they are key carbon sinks, but warming, wildfires and even insect outbreaks could affect their survival. Insect outbreaks is a strange one, because while you would expect some activity to take place before climate change, with the increasing temperatures, more and more species will be able to move into the area. We would call these invasive species. This could release massive amounts of carbon back into the atmosphere, further again exacerbating climate change. As we've already stated before, this could lead to release of carbon from the pedosphere, not just the biosphere. However, it's not all doom and gloom. With increasing temperatures, we'd expect to see some form of negative feedback in the carbon cycle. While the following won't drastically solve our problems, they will help to mitigate some of the emissions released. For example, increased vegetation growth or carbon fertilization. High levels of atmospheric carbon dioxide can boost plant growth, enhancing photosynthesis, particularly in areas where it might have been too cold for excessive plant growth in the biosphere before. This allows ecosystems like tropical forests and grasslands to absorb more carbon, at least temporarily, helping to slow the rise in atmospheric CO2. We call this process sequestration. Another mechanism is the chemical weathering of rocks. When CO2 mixes with rainwater, it forms carbonic acid, which reacts with the rocks, particularly those of alkali base. like calcium carbonate, otherwise known as limestone or chalk. This process removes CO2 from the atmosphere, transporting it to the oceans where it's stored in the form of carbonate. This is then either slowly deposited on the ocean floor, about 10% at the moment, or is taken up by different organisms to form calcium carbonate, for example polyps, making their coral exoskeleton. Over time, this acts as a powerful carbon sink, though calcium carbonate cannot form if the concentration in the ocean continues to increase, as the pH will lower, making the oceans too acidic for formation of calcium carbonate or alkali-based minerals. And finally, our last mechanism we would expect to see is Arctic greening. So as the Arctic warms, areas once too cold for vegetation would now sprout shrubs and grasses. We call this process succession, as life begins to take place on bare rock surfaces. These plants would absorb carbon dioxide through photosynthesis, creating a new carbon sink in a landscape that would have been previously barren and devoid of life. While tipping points do threaten to accelerate climate change, these negative feedbacks remind us of Earth's natural resilience. Still, the window to act is shrinking. We need to limit our warming to 1.5 degrees centigrade, or these tipping points will all occur. By understanding and addressing these processes, we can work to stabilise the Earth's climate and secure a sustainable future for everybody. Thank you for your time in listening to Bon Hill Geography.